So we're going to go over simplifying expressions. And the first one, when we get this type of situation, we have two operations beside each other and there's really no value in between them. Do you recall your multiplication of integer rules at all? A little maybe?
Kind of.
Okay, so let's say we have a positive times a positive. That's also equal to a positive, your answer. Okay? A negative times a negative is a positive. And then anytime you have opposite signs, so positive by a negative, you get a negative answer. So, with that being said, the idea here is think of these like we're going to multiply the two operations together without a value. This is a positive times a negative, which is going to give us what? Which of the three rules does that apply to? Positives. That's right. So instead of writing two values, okay, what we're going to do is we're just going to combine it into one value. So our one value will now read x, and we combine the two into just one sign, minus, okay, 3 equals 8. Okay? So we have that now. That's been simplified. But we have to isolate for x, which means we want to get x by itself, and we want to move, what happened there? We want to move the negative 3 to the other side, right? Think of this equal sign like a wall, and everything just moves left or right of the wall. So when we move negative 3 over, we actually have to use the opposite operation. So because it's a negative on this side, it becomes positive. And that's what we're making the arrow for, okay? So then it's very simple. We just have to simplify the one side. X is equal to 8 plus 3, which is 11, okay? Here's another one. Now this is a distributive property question. Though it doesn't look like it, it looks like 5 minus this bracket here, which is 6x plus 2 equals 1. Well, this negative sign, think of it actually like it's almost like negative 1 is being multiplied by these brackets. So we have to multiply or distribute our negative 1 to all of those values. Okay, so the 5 still stays out here. But when we multiply negative 1 times 6x, we get negative 6x. And when we multiply, and I'm just going to put arrows to see that we did that. When we multiply negative 1 times 2, we get negative 2, okay, is equal to 1. Now we're going to take our terms here. We have 5 and negative 2. Those are our like terms. This negative 6, this still stays negative even though we've kind of moved it to the left now. And we have 5 minus 2 is going to give us positive 3 equals 1. Okay. Now the goal is to get x by itself. Well, the thing that is farthest from x, and this is where you kind of think of reverse BEDMAS. Normally with BEDMAS we deal with our multiplication first, but because we have addition, we're going to deal with this first, and we're going to move those values to the other side. So when I move the positive 3 to the other side, what do we end up at?
1 minus 3.
That's right, we subtract the 3. When we subtract 3, we get negative 2. So we have negative 6x equals negative 2. Oh, that's new. I'm going to have to change it. Sorry.
It's okay.
So we still got to isolate x. Now this says negative 6 times x. So how do we get that negative 6 times x?
You divide both sides by negative 6.
That's right. So we divide both sides by negative 6. This negative 6 is on the left side of the equation. Cross out and we have x. And here it becomes, well, two negatives, when we divide them, it's the same as multiplying, we'll get a positive. So we could say it's positive 2 over 6, or we could reduce the fraction, which is 1 over 3, or we could write it as a decimal. All of those are acceptable answers. Okay? So there's everything we quickly did. Don't know where the recorder went. Sorry. Oh, there it is.